Welcome to qnawire.
So we are asked which of the pairs has lower delta H hydration. And so delta H hydration is actually related to the charge to volume ratio of my constituent ions that I need to dissolve. So lower ratio means lower delta H of hydration. Why? Hydration is basically the energy released once the intermolecular forces form between the water and the separated ions. And basically the lower, and this is of course going to be exothermic, and the lower charge to volume ratio, the easier this hydration is going to be due to the easier formation of the water molecules around my ion, and hence the more exothermic or the lower the delta H hydration is. And so in my solution to problem 33, we indicated the ones that have a lower charge to volume ratio. And so here, A between an ion, iodine and bromine, iodine has a lower charge to volume ratio. And so it's going to have the lower energy of hydration. For B, between Sc3 plus and Ca2 plus, Ca2 plus has a lower charge to volume ratio, and so it's going to have the lower hydration. And similarly in C, between Br minus and K plus, Br minus has the lower charge to volume ratio and hence the lower enthalpy of hydration, and Cl minus has the lower has lower charge to volume ratio compared to a sulfur or a sulfide ion, and so it's gonna have a lower hydration enthalpy. And just similarly, as we have solved or as we have explained in part 3 or in solving problem 33 of the same book, in this case, this has the lower charge to volume ratio, and so it's going to have the lower enthalpy of hydration. And here, in case of ionic compounds, as we said, this has a lower charge, similar size, and so this has a lower charge to volume ratio, and so it has the lower hydration. Here, between the two iron ions, this has a lower charge to volume ratio, and hence lower enthalpy of hydration. And finally, between Ca2 plus and K plus, as we said, this has the lower charge to volume ratio due to both lower charge and higher volume. And so